Hello, good evening, guys. Hello, guys. Good evening. Welcome back to the sessions. How was your day today? Please comment in the comment section. All of you, good evening. Can you hear me? Am I clearly audible? Yes. So yesterday we saw questions from electric charges and fields, and today we will have a discussion of questions from electromagnetic induction first. Then later on, Rafi sir will handle a session on current electricity. Okay. So shall we go straight away to the questions, or should we wait for some more time? Good evening, everyone. Good evening. Good evening, Adi. Good evening, Devika. All of you. Sadiq, Johnson. All of you, good evening. Okay, so let us get straight away to the questions. Now these are very important questions. All are carefully selected. All are the ones which have high possibility of coming in examinations. So make sure that you learn the questions, every single question properly. I'll give you the equations and whatever theory is needed before I do the questions. Okay, so I am moving to the first question now. Shall we? Yes. Okay, so here we have the first question. The magnetic flux linked with a coil in Weber is given by equations phi is equal to 3t square plus 4t plus 9. Okay, so they have given you the equation for flux. Flux is given as what? 3t square plus 4t raised to 1. It is given 4t, but I am writing it as 4t raised to 1 plus 9. So you are given the value of flux, or rather the equation for flux. And what is the question? You are supposed to find the EMF induced at 2 seconds. Okay, so you got to find what? EMF induced at 2 seconds. Okay, so the equation here is EMF is equal to minus d phi by dt. Now this is known as Faraday's law, or rather Faraday-Lenz's law. As per original Faraday's law, it is simply F is equal to d phi by dt. Sorry, EMF is equal to d phi by dt, rate of change of flux. But here we put a negative sign because Lenz's law says so. According to Lenz's law, EMF is negative of d phi by dt. What does this negative sign stand for? Negative sign tells you that the EMF generated will oppose its cause. Will oppose its cause. Okay, so the EMF is given by negative of d phi by dt. So that is equal to minus d by dt of, I'm just substituting for phi here. What is phi? That is 3t square plus 4t raised to 1 plus 9. Now I'm differentiating one by one. Look at this. Minus is still outside. What is the differentiation of 3t square? Differentiation of t raised to n, we have a formula. This is n t raised to n minus 1. Okay. Differentiation of t raised to n is n t raised to n minus 1. So how about this one? This 3 is a constant. I can get it outside. So minus of 3 into. What is the differentiation for t square? In place of n, we got 2 here. So what is it going to be? 2 into t raised to 2 minus 1. So that makes it 2 into t raised to 2 minus 1 is 1. Plus the next number is 4. I can keep the constants apart. Constants are to be kept aside. Okay. And what about differentiation of t raised to 1? Look at this. 1. In place of n, what I've got is 1. So how do I differentiate it? Tell me. That is 1 into t raised to 1 minus 1. 1 into t raised to 1 minus 1. 1 into t raised to 1 minus 1 is 0. Last one is a constant. If a constant stands alone, the differentiation is what? Differentiation will be 0. So I can expand it now. That is equal to minus of, this is 3 into 2, that is equal to 60 plus, tell me what this is. T raised to 0, any number raised to 0 for that matter is 1. So what is it making it? 4 into 1 into 1, that makes it 4. Okay, so this is the equation for EMF now. And what I'm supposed to find is the EMF at 2 seconds. How am I finding it? I can put the value for time. EMF at 2 seconds is my question. EMF at 2 seconds. Okay, how to find it? Put this time value wherever you find t. That's it, end of it. So minus of 6 into, in place of time, I can put 2. 6 into 2 plus 4. So what is this now? 6 into 2 is 12. 12 plus 4 is 16. It is minus of 16. But see this, they are asking for magnitude of induced EMF. So forget about the minus sign. You just keep the magnitude. So what is it now? The magnitude is 6 into 2, 12. 12 plus 4 is 16 volts. Here the answer is option D. All of you understood this? Come on guys, tell me, understood? Hello? Anybody wants this to be repeated? Hello? Tell me in the comment box. Everyone. Hello, can you hear me, everyone? Right. Thanks for that, everyone. Now, there is an allied question here. I'll tell you. Look at this. You know, you can have, just give me a second. You can have an allied question. They might ask you to draw the graph of EMF against time. EMF against time. Look at this equation. EMF is given by minus 6. I'm expanding this into bracket. Minus sign into 6, minus 60, minus into 4 is minus 4. And this looks like y is equal to mx plus c. So what will be the nature of the graph? What will be the nature of the graph? I'm wiping it. Right, I'll draw the graph here. So this is my equation now. EMF is given by minus 60 minus 4. And the equation here is y is equal to mx plus c, which obviously represents a straight line. This is the equation for straight line, right? You must have seen this many times in class 12. Okay, so what is in place of y? In place of y we have EMF. In place of x we have time. So on y-axis I'll take EMF, and on x-axis I'll get time. So I can draw the graph now. Look at the graph. Here the slope is negative. Slope is negative. Look at the slope is m. Slope is negative, right? Slope is negative, and y-intercept is also negative. Y-intercept is also negative. So you can draw the graph this way. It's going to be a straight line. Y-intercept is negative means the C actually tells you where the graph starts from. It is starting from where? It is starting from, look at this, 1, 2, 3, 4. It is starting from here and the graph is going this way. So that is how the graph is asked in this question. So for this question, answer is 16 volt, and they might ask you to draw this graph as well. Understood this? Everyone, all of you, tell me please. Shall I go to the next one now? Everyone, can you hear me? All of you, can you hear me? I'm having a latency here. I'm having a lag of 30 seconds. That is why I'm asking. Right. Okay, so moving to the next question now. Question number 2. If a coil of 40 turns and area 4 centimeter square is suddenly removed from a magnetic field, see this? It is removed from a magnetic field. Okay. It is observed that a charge of 2 into 10 raised to minus 4 coulombs flows into the coil. If the resistance of the coil is 80 ohms, the magnetic flux density is. So see that again. What all things are given? Number of turns is given. We got a coil. The number of turns is how much? Number of turns is given 40. Right? So there are 40 turns for the coil. And area is given. How much is the area? Area is given as 4 centimeter square. Centimeter square can be written as 10 raised to minus 4. Why do I write 10 raised to minus 4? Centimeter square is to be converted to meter square. Centimeter square is to be converted to meter square. Okay. And then it is removed from a magnetic field. It is removed. Look at this. So look at the context. We have a magnetic field, and a coil is kept inside. Okay. And you are removing it. Removing it means what? It is getting out. Right. So what is a magnetic field? Electric area now? Area, you can call it 0. Why? Because in the first case, the entire area was inside the magnetic field. Look at this. The entire area was inside the magnetic field. Now you pull it outside. They say it is removed. Removed means what? The area goes outside. Area goes outside means final area has to be called 0. Final area has to be called 0. Then what else is given? Charge is given. They have given you charge. And even the resistance is given. So what is the question? The equation for charge is dq is equal to minus d phi by r. You must have learned this before. Or should I do that? I can show you. Look at this. I can show you. Look at this. You know, how do I get the equation for charge? dq is given by I into dt. Induced charge, right? Or you can get this from this equation. I is equal to dq by dt. This is from current electricity. Right. So we learned that current is given by dq divided by dt. dq by dt. And if you cross multiply, you get dq as I into dt. What is current? Ohm's law tells you that current is EMF by resistance or voltage by resistance. Voltage by resistance into dt. Into dt. What is EMF? Just now we learned EMF is minus d phi by dt by r into dt. Now dt and dt are getting cut. And eventually you are left with minus d phi by r. dq is equal to minus d phi by r. Now actually you won't need this. This was done just to show that induced charge is given as minus d phi by r. So see that again. Current is given by dq divided by dt. Cross multiply. Then charge will be equal to current into time. Current is given by Ohm's law, EMF by resistance into dt. And EMF is substituted as d phi by dt. dt and dt are getting gone. And you are left with minus d phi by r. So this is the equation I'm going to use here. Induced charge is given by what? induced charge is given by minus d phi by r. Induced charge is given by minus d phi by r. That is equal to minus d of what is phi? Phi is given by NBA divided by r. Why? Because you learned that flux is B dot A or BA cos theta. Okay, I repeat one more time. In the case of electromagnetic induction, induced charge is given by dq is equal to minus d phi by r. This is very important. Okay, induced charge is given by minus d phi by r. What is d phi? D phi is the change of flux. D phi is the change of flux. What is r? Resistance of the coil. Resistance of the coil. Okay, now what? You know, you can put this phi value. What is phi value here? What is phi value here? Look at that. Phi value is NBA. Number of turns, magnetic field, area. So I can get the numbers out. Tell me what you get now. I'll get these numbers out. Minus N will be taken outside. B will be taken outside because they are constants. Then what else is inside? Only area is inside. D of A divided by R. Okay, this is actually induced charge. So I repeat the points one more time. Induced charge is given by minus d phi by r. Minus d phi by r. What is minus d phi? D phi is the change of flux. How do we get change of flux? Tell me, how do we get change of flux? Oh no, tell me please. Change of flux is minus of NBA divided by R. I'll get the constants outside. N comes outside. B comes outside. I'm getting only A inside. Now let us put all the values. They have given you the values here. The charge is given 2 into 10 raised to minus 4, right? And then what? Number of turns is given. Magnetic field is to be calculated. They are asking you to find magnetic flux density, which is nothing but this number, magnetic flux density. You can substitute and find out. I'm giving you 5 seconds to write this so that I can wipe it off and calculate the final value. All of you understood this? Everyone, please tell me, everyone. Okay. So, okay, fine, right. Okay, so this is my final equation. I'm going to substitute here. So that was my final equation. dq is equal to minus NB dA divided by R. So I substitute for everything. Induced charge is given. How much is the induced charge? I've been given the induced charge here, okay? Induced charge is 2 into 10 raised to minus 4. Then that is equal to minus number of turns is given in the question, that is 40. Magnetic field is to be calculated. I'll retain it. What is difference of area? Final area minus initial area. Final area minus initial area. What is it? I'm finding it here. Difference of area is final area, that is 0 minus initial area. 4 into 10 power minus 4. What is it now? That is equal to minus 4 into 10 power minus 4. Okay, so I'm putting it here. Minus 4 into 10 power minus 4 divided by resistance of the coil is 80. So tell me what now? Now it is simplification. So 40 and 80 are cut. This is 2. 2 and 4 are cut. This is 2. Then 2 and 2 are cut. 10 power minus 4 gets gone. Finally you have B is equal to 1 Tesla or 1 Weber per meter square, and the answer is option B. All of you understood this? Everyone please, come on everyone. Understood this, everyone? Tell me, these are repeated questions, charge questions you can expect. Induced charge. Okay, induced charge is very, very important. Induced charge is given by minus NB into dA divided by R. Hope you got it. Shall we go to the next one now? Everyone, please, everyone. Right. Okay, thanks for that. Right. Okay, so let us go to the third one now. This is another question on charge. Let us see this. A circular coil of 500 turns. Circular coil of 500 turns. So number of turns is given. Has an enclosed area of 0.1 meter square per turn. 0.1 meter square. It is kept perpendicular to a magnetic field of induction 0.2 Tesla. So magnetic field strength is given. Then what? It is rotated by 180 degree. It is rotated by 180 degree. About a diameter perpendicular to the field in 0.1 second. So let us write everything. I am writing the number of turns here. Number of turns is 500. They have given it over here. Number of turns is 500. Okay, number of turns is 500. And area is given. Area is 0.1 meter square. 0.1 meter square. Okay. It is kept perpendicular to a magnetic field of 0.2 Tesla. Magnetic field is what? 0.2 Tesla. Right. And it is rotated by 180 degree. What does it mean? You know, when a coil is rotated through 180 degree, I'll just draw this. Look at this. Imagine this is the magnetic field. North pole. This is south pole. Okay. And the field lines are from north pole to south pole. North pole to south pole. Like this. And imagine you are keeping a coil inside like this. Where is area vector? Where is area vector? Area is always perpendicular to the surface. Perpendicular to the surface. And what I'm doing is, see, I'll just rotate the coil like this. What will happen now? The area vector will turn to the other side. Okay. So this is what is meant by rotating the coil through 180 degree. So the actual method I won't tell you. Instead, I'll tell you the shortcut. Whenever you see this, when a coil is rotated through 180 degree, or they say flux is reversed. Flux is reversed. What is the meaning of it? Instead of rotating the coil, in order to have the same effect, you can turn the polarity, right? You can change the polarity. The north and south may be interchanged. You will have the same effect, right? So, if the coil is rotated through 180 degree, or they would say flux is reversed. Flux is reversed. It's a multiple times asked question. You know, whenever you see this, we have the shortcuts. I'll tell you the shortcuts. EMF is given by 2NBA by dt. You can get this from original Lenz's law equation. Okay. But I'm not trying it. It will take time. Okay. And induced charge is given by 2NBA divided by R. I repeat the question one more time. Look at this. What is the context here? What is the context here? You know? Okay, what is the context here? So this is what it is. We have a coil. This is a coil. Where is the coil kept? The coil is kept inside a magnetic field. Inside a magnetic field. And what are you going to do? You're going to rotate the coil through 180 degree. You will rotate the coil through 180 degree. Or you will reverse the polarities. Tell me, that is called flux is reversed. Both cases, this is the equation. EMF is given by 2NBA by dt and induced charge is given by 2NBA divided by R. What is N? The number of turns. B is the magnetic field strength. A is the area. dt is the time in which this happens. Okay. And in the case of charge, what is R? The resistance of the coil. So hope you have written this down. Tell me if you have finished writing this. Everyone, all of you, come on guys, tell me please. The faster you respond, the more we can do. Everyone. Can you hear me? Am I audible? Right. So, hope you have written this equation. This is such an important question. You will see this on paper for sure. Right. What are you doing? You are turning the coil around or you are changing the polarity. So, in that case, EMF is given by 2NBA divided by R, or flux is given by 2NBA by R. Keep this in mind and then let us go to the questions. They say, how much charge? They are asking about charge. Obviously, the second equation. How are we going to do it? Look at this. I'm just wiping it off. Okay. So, what is the equation for induced charge? It is given by 2NBA by R. This is in fact a shortcut. 2NBA by R. You can put the numbers and then find the final value. What is the number? N 500 turns. Number of turns. Magnetic field 0.2 Tesla. Area is 0.1 meter square. Divided by resistance. Resistance is given 50 ohms. 50 ohms. So let us cut them out. 50 and 500 cut 10. What do we get now? 10 into 0.2, that is 2. 2 into 2, 4. 4 into 1, 4 into 0.1, 0.4 coulombs would be the final answer. 0.4 coulomb answer is option B. And some of you might have a confusion. Now, is it not area per turn? So, will you have to multiply again? No. Actually, the coil looks like this and the area is common. Area is common. You just have to take area only once. It is already included. So, this is how you do this. It's an important question. Whenever a coil is rotated through 180 degree or flux is reversed, EMF is given by 2NBA by dt. Induced charge is given by 2NBA by R. And this question is about finding charge. So I'm using the second equation. Hope you got it. Shall we go to the next one now? There are very important questions coming up. Tell me. Come on guys, what is this? Tell me please. Okay, right. Okay, so let us move to the next one now. Now this is based on motional EMF. Look at this. Two rails of a railway track insulated from each other and ground are connected to a millivoltmeter. Okay, so I'll illustrate the situation. This is a railway track, okay, and there are two wheels and the rod connecting them is called axle, AXLE. Okay, so this is the situation. I repeat this, let us read it first. Two rails of a railway track insulated from each other and the ground are connected to a millivoltmeter. So these rails are connected to a millivoltmeter. Okay, what is the reading of the voltmeter? So the question is to find the reading of voltmeter, or in other words, voltage. So you have to measure the voltage. Okay, when the train travels with a speed of 180 km per hour along the track, given that vertical component of Earth's magnetic field is 0.2 into 10 raised to minus 4. What is meant by vertical component? That part is deleted now, but even then you may have this question. Earth's magnetic field has two components. One is vertical component, the other one is horizontal component. Okay, imagine a train is moving. When the train is moving, the axle is cutting what? Imagine my hand is axle. The axle is cutting what? Axle is cutting vertical component, right? Axle is cutting vertical component. So in the question, they have directly given vertical component. Okay. Now let us read the question. What all things are given? Speed of the train is given. Speed of the train. How much is the speed of the train? 180 kilometer per hour. 180 kilometer per hour. Why should I multiply with 5 by 18? Kilometer per hour is to be converted to meter per second. If you want to convert kilometer per hour to meter per second, this is what you do. 180 into 5 by 18. So 18 and 18 are cut. 10. So you will get what? 10 into 5 is 50 meter per second. One of the most repeated questions ever. Right. 50 meter per second. So I got the velocity, right? Then what else is given? Magnetic field is given. Vertical component of magnetic field. That is exactly what we want. Vertical component is given. How much is it? 0.2 into 10 power minus 4 Tesla. Weber per meter square is same as Tesla. Weber per meter square is same as Tesla. Okay. And the rails are separated by 1 meter. The rails have a separation of 1 meter. Rails have a separation of 1 meter means the axle also has a separation length of 1 meter. Oh, tell me, the rails are separated by 1 meter means the wheels are separated by 1 meter. So this axle has a length of 1 meter. So length is also given 1 meter. This is a case of motional EMF. You learn whenever a conductor moves in a magnetic field, the EMF developed between the ends of the conductor is given by BLV. I'll tell you, imagine you have a magnetic field and a conductor is moving inside this. Look at the conductor is moving inside this. What will happen? All the electrons will be pulled to one end of the conductor. Okay, so imagine the electrons are all going down, so they are all clustered at the bottom. Now the top end will be what? Positive. Correct, because electrons are going down, electrons are clustering at the bottom, so the top will be what? The top end is losing electrons. So losing electron means it is positive. So this is called motional EMF. Actually, this is acting like a cell now. Okay, so how to find the motional EMF? It is given by the equation BLV. B is the magnetic field, L is the length of the conductor, V is the velocity of the conductor. So I can directly put the values. That is, what is B here? 0.2 into 10 power minus 4. I said before, vertical component is as such given. We need vertical component only, right? Because when the train moves, it is cutting vertical component. Okay, vertical component. All right, into length of the conductor. Here our conductor is what? The axle, right? Axle length is 1 meter, they say. In some cases, they'll say meter gauge train. They won't say the length is 1 meter. Have you been to the Darjeeling, the toy train? Have you been on this toy train? In Ooty or in Darjeeling? You know, those trains are very small. Like they have a width of like 1 meter only, unlike the normal trains. So it is called a meter gauge train. So when they say meter gauge train, one thing is implied. What is it? Meter gauge means the distance is 1 meter. Distance between the rails is 1 meter. So length of the conductor, if they say meter gauge train, you have to automatically take the length of conductor as 1 meter. So put it over here into velocity. How much is the velocity? 50 meter per second. So tell me what you're going to get. 50 into 2, 100. One place down, 10 into 10 raised to minus 4. So that's going to give you 10 raised to minus 3 volts. So this is an important question, as I told you. Same question came once with the case of an aeroplane. Imagine an aeroplane is flying. In that case, the wings of the aeroplane will be taken as the conductor. Look at this. This is one wing of the conductor, another wing of the conductor, right? So this is aeroplane, right? So, you know, the end-to-end length, the tip-to-tip length of the wings or that is called wingspan. Wingspan would be taken as length of the conductor. This is again a repeated question. So motional EMF question is very, very, very important. This is what you have to know. Whenever a conductor intercepts a magnetic field, whenever a conductor moves in a magnetic field, a voltage is developed between the ends. This is known as motional EMF, and motional EMF is given by BLV. Got this, all of you? Shall I switch to the next one? Everyone got this? So here the answer is, 10 raised to minus 3, answer is option C. Please tell me. Yes. Many are. Okay, right. Tell me, everyone. Come on, guys, tell me, please, everyone. The faster you respond, the more we can do. All right. Okay, right. So let us move to the next one now. A wheel, again a repeated board examination question, but this actually came as a descriptive question. All right. I'll read the question. A wheel with 10 metallic spokes. See this? 10 metallic spokes. How many spokes are there? 10 spokes are there. A wheel with 10 metallic spokes, each 0.5 meter long. So number of spokes is given. How many spokes? 10 spokes. What is a spoke? This is a wheel, cycle wheel. And there are spokes on it like this. Okay, each rod is called a spoke. Okay, so number of spokes is given, the number of rods is given, it is 10. Then it is rotated with a speed of 120 revolutions per minute. 120 revolutions per minute. That is called frequency. 120 RPM. You might have heard about RPM of your car, right? Revolutions per minute. That means it is rotating how many times in a minute? 120 times in a minute. But I need it in seconds. How to convert this to seconds? Whenever it is given in RPM, convert it to RPS. How do we do that? You divide with 60. That is the first thing to do. Tell me what you're going to get. This and this are getting cut. You get RPS, 2 rotations per second. Or in short, I could say that the wheel is rotating how many times in a second? 2 times in a second. Why do I need this? So that I can find out omega. Omega is called angular frequency or angular velocity. It is 2 pi times f. Angular frequency or angular velocity, that is equal to 2 pi into frequency is given 2, that is equal to 4 pi radians per second. Okay, so I got the omega value, I got the number of turns. Magnetic field also must be given. Yeah, magnetic field right here. Magnetic field is what? They say it is 0.4 Gauss. Gauss is CGS system, CGS unit. How to convert it to SI? 1 Gauss is 10 to the power minus 4 Tesla. 1 Gauss is 10 to the power minus 4 Tesla. Now you got everything, right? What is the question? The induced EMF between axle and rim of the wheel. Look at this. Axle, this is called axle, the center. This is the rim. Now look at all the rods. This rod is connected between the center and the rim. This rod is connected between the center and the rim. The third rod is connected between center and the rim. Fourth rod is connected between center and the rim. Or in short, all the rods are connected between center and the rim. Which means what? All are connected between same pair of points. Which means what? They are all in parallel. In parallel means what? We never count the number of cells. See, we learned that in current electricity, right? So, number of cells won't matter at all. Number of spokes won't matter at all. Be it 1 spoke, 10 spokes, 1000 spokes, 10,000 spokes, 1 million spokes, or even 1 billion spokes, you will always take what? The motional EMF as B omega L square by 2. This is the equation for motional EMF for a rotating conductor. Rotating conductor means one end of the conductor is fixed, the other end is rotated. Like the fan of a helicopter, or spokes of a cycle wheel. But as you can see, here all the spokes, hear me again, all the spokes are connected between the center and the rim. Center and the rim, center and the rim, center and the rim, center and the rim, which means all are in parallel. In the case of parallel combination, number of cells is never counted. Okay, so number of spokes is irrelevant. We won't count it. Okay, there was a sub question for this question, previous paper question. All right, they were asking like, what if the number of spokes was increased? Nothing would happen. Okay, so I can put the values now. What is the magnetic field? It is given 0.4 Gauss. So 0.4 into 10 power minus 4 Tesla. Omega is given here. It is 4 pi. And length of the conductor is given here. Where is it? 0.5. Length of the conductor is 0.5, which may be called half. 0.5 is half. 0.5 is half. So L square by 2. What do I get? 2 and 2 are cut with, look at this. 2 and 2 are cut with 4. Then this 2 is cut with 0.4, leaving you with 0.2. So what do I get now? Finally, I get 0.2. Then there is a pi into 10 power minus 4. Okay, so let us look at the answers. You know, I take it one place up. 2 pi. If I take it one place up, I should make this 10 to the power minus 5. One place up, you have to add 1 here, right? So it is 2 pi is what? Pi value is 3.14. 2 into 3.14. 6.28 into 10 power minus 5 volt. That will be the EMF developed between the center and the rim. So you just have to know two things. In the case of a cycle wheel, number of spokes is never taken into account. Okay, and the EMF is given by B omega L square by 2 for a rotating conductor. B is the magnetic field, omega is the angular velocity, and L is the length of the conductor. All of you understood this? Can I have a response, please? Everyone, let's make it quick. I got only 15 minutes. Please, everyone. Tell me, please, everyone. You have the exam in another 3 days. Tell me, these are all important things. Sure marks. Then why? Right. We chose the sessions that way. We thought of giving importance to the first part because this part, you're going to get the questions. These are calculation, the numericals. Okay. Right. Thank you very much. Now, moving to the next question. Now, this is what, as shown in the figure, a metal rod makes a contact and completes a circuit. So, we have a circuit here. You can see this, it's a circuit. There is a metal rod. Okay. And the circuit is perpendicular to the magnetic field. The circuit is perpendicular to the magnetic field with B is equal to 0.15 Tesla. So, I am writing the magnetic field. Magnetic field is 0.15 Tesla. Okay. Then what? Resistance is 3 ohm. If the resistance is 3 ohm, tell me about it. Resistance is 3 ohm. Then what else is there? Force needed to move the rod as indicated with a constant speed of 2 meters per second. Speed is also given 2 meters per second. Okay. Now I'll tell you how to calculate the force. You must have learned this in school because it's an important reader point. Okay, but anyway, I'll do that. This is how you do it. First of all, what is given? What is the equation for power? It is given by E square by R. This is called Joule's law of heating. Power, electrical power is given by E square divided by R. EMF square divided by R. What is EMF? Just now you learned motional EMF. BLV the whole square by R. BLV the whole square by R. That makes it B square L square V square by R. So this is the equation for power, right? Okay. So electrical power they may ask. Electrical power or even mechanical power they may ask. Whatever power it is the same thing. Got it? Now I need to find out the force. How to find the force? I'm going back to class 11. Force is given by power by velocity. I don't have to prove it, but anyway, you have learned this in school, I believe. Force is equal to power by velocity is so important, given in the reader. Power by velocity. What is power? I've gotten it over here. B square L square V square by R by V. So cut this with V. So finally I have the equation for force. What is the equation for force? B square L square V by R. This is so important. Force required to pull a conductor is B square L square V by R. Here everything is given. B is given 0.5 Tesla, R is given 3 ohm, velocity is given 2 meter per second, length of the conductor is also given 50 centimeters. You might not notice, but it is given in the figure. Length of the conductor is 50 centimeters, which may be called half meter. All of you understood until here? If you could write this down, I can solve further. Everyone, can you please tell me? Can we make it fast, little more fast? Could you please respond? Everyone. Thank you very much. Thank you, Sadiq. Right, Hibba, Adi, rest of the guys, could you please tell me? Farhan, yes, I can see you. Sean, right, thank you very much. All of you please, everyone. Sanush, Johnson, all of you. Right, so I'm directly substituting for this, so keep this equation in mind. I'm going back now. Now look at that. I can write the equation for force now. They are asking for force. B square L square V upon R. What is B square? I've got it over there. 0.15 square into length square. What is length? Half into half. Velocity square. What is velocity? Velocity is given 2. Velocity square 2 into 2. Oh no, only one velocity. It is not V square, it is only V. Divided by R. R is how much? 3 ohms. Let us cut the common terms now. 2 and 2 are cut. Then finally what do we get? Right, that is equal to 0.15 square. 0.15 square is 0.0225. 15 square is 225, right? But 4 places down. You tried yourself. Into this 2 will go to denominator. So this 2 will go to denominator and 3 also goes to denominator. You can try it yourself. Okay. So it's like, this is like 225 into 1, 2, 3, 4 places. 10 power minus 4 by 2 into 3, 6. If you cut it, it's somewhere around 30, 180, 45, 37. You're getting something like 37. 37 into 10 raised to minus 4. 37 into 10 raised to minus 4. 1 place down, 3.7 into 10 power minus 3 Newton. Is there such an option? 3.7 into, yes. 3.7 into 10 power minus 3. 3.7 into 10 power minus 3 Newton. That will be the force. All of you got it? That's an important question again. So this is the final answer, 3.7 into 10 power minus 3 Newton. Answer is option A. All of you got it? Can I have a response, please? Everyone. Tell me, please, your response is what motivates me. Then what? Right. So, yes. Let us go to thanks for the response, everyone. Okay, right. So moving to the next one, 8th question. This is based on self-induction. Self-induction, hope you remember what it is. Self-induction. we have a coil here and we connect a cell and a switch. Okay? When you switch it on, what will happen? Current will start increasing, right? Current will start increasing. Current does not become maximum all of a sudden. Current will take time to grow to become maximum. Okay, that growth stage is called transient stage. Forget about that for the time being. Just know that when you switch it on, current will start increasing. When current increases, what happens to magnetic field inside solenoid? That will increase because current is causing magnetic field. When current increases, magnetic field also increases. When magnetic field increases, flux increases, right? And what did Faraday say? Whenever the flux changes, an EMF is developed. Whenever the flux changes, an EMF is developed. What is the equation for EMF? In self-induction, the equation for EMF is minus L into di by dt. Minus L into di by dt. So let us write everything given. When the current changes from plus 2 ampere to minus 2 ampere, what does it mean? I1 is given plus 2 ampere. I2 is given minus 2 amperes. So you're just reversing the current. So what does that give you? DI. You will get DI. DI basically stands for what? Difference in currents. Difference between currents. Difference between currents. How do we take difference between currents? I2 minus I1. Final current minus initial current. Final current minus initial current. Final current minus initial current. Final current is minus 2. Initial current is 2. So minus 2 minus 2 minus 4. So let us come and put over here. EMF is given. EMF is given 8 volt. EMF is given. 8 volt is developed, right? They say the current is changing and EMF is developed. And this is called self-induction. The phenomenon is called self-induction. Okay. So let us put it here. EMF is given as 8 minus, you have to find self-induction, coefficient of self-induction. So L has to be found out. Okay. What is the question here? EMF is given as 8 volts. Self-induction I need to find out. What is DI? Change in current is given, that is 4. By what is the time taken for all these? Time taken, oh, this happens in 0.05 seconds. I should have written the data first, but unfortunately I don't have the space here. Okay. And excuse me for that. So I'm just taking the data wherever needed. This is what? EMF is 8 volts and self-induction is to be found out. What is the change in current? Change in current is minus 4 divided by time is given 0.05. Tell me what you're going to get. You can cross multiply 8 into 0.05. Cross multiply 8 into 5, 40. 2 places down, it is 0.4 is equal to minus or minus plus 4 times L. If you cut 4 with 4, you are getting 0.1. So finally, L is equal to 0.1 Henry. Henry is the unit of self-inductance. Understood this? Again, a previous question. All of you got it? Can I have a response, please? Just put a thumb. Okay, answer is option A. Yeah, many are responding. Very good, very good. Right. Answer is option A. Option A. All of you got it? Self-inductance is? Yeah, right. So I'm moving to the next one now. Okay, right. Moving to the next one now. This is a little more complicated. It is mutual induction question. A solenoid has 2000 turns. So number of turns is given. Solenoid has 2000 turns. So number of turns is given 2000. Wound over a length of 0.3 meters. So length is given 0.3 meters. The area of cross section, how much is the area of cross section? Look at the area of cross section. It is 1.2 into 10 power minus 3 meters square. Then what? As around the central section, another coil of 300 turns is wound. So obviously there are two coils. Look at this. This is the situation. We have a coil. Around the central section, you are winding another coil. So it must be a case of what? Two coils together. It is called mutual induction. Mutual induction. Okay, mutual induction. So let us go on. Number of turns is given. What is the number of turns here? Number of turns is 300. So one of them may be called primary number of turns. The other may be called secondary number of turns. Why? Why? Because number of turns, one can be called primary, the other can be called secondary. It doesn't matter which one you call primary or which one is secondary. Okay. Now this is NS, NP, then what else is there? The current of 2 ampere is reversed. Look at that. That point is very important. Reversed. So current is reversed. Reverse means what? First current is how much? 2 amperes. First current is 2 amperes. You are reversing it means second current is minus 2 amperes. Why do they give this? Why do they give this? Can someone tell me please? Why do they give this? Because you've been given I1 and I2. Now you can find out DI. What is DI? Final current minus initial current. Final current minus initial current. Final current minus initial current. DI is actually the difference between currents. Okay, so tell me what you're going to get now. This is minus 2 final. Final current is minus 2. Minus initial current 2. That's going to give you minus 4. I got everything now. Tell me what? The question is induced EMF. That's easy now. Right. What is the equation for induced EMF? We are talking about mutual induction. Mutual induction. Do you remember the equation for mutual induction? EMF is given by minus M into di by dt. Just like self-induction. That was L into di by dt. In case of self-induction, it is called L. And in the case of mutual induction, we call it EM. So here everything is given. What am I supposed to find out? EMF, right? So first of all, I have to find EM and I have to substitute. How to find EM? If you remember the equation for EM, this is what it is. Mu 0 Ns Np A by L. Mu 0 Ns Np A by L. Let me do that very quickly. Mu 0 value is 4 pi into 10 power minus 7. Number of turns in primary is 2000. Number of turns in secondary is 300. I'm wiping this part. Area 1.2, length is 0.3. Keep that in mind. Oh, no, right. So, I'm really sorry. This is 2000 into 300 into number of turns in primary area. Area is 1.2 into 10 power minus 3 divided by length is 0.3. So let us get the identical terms cut. 0.3 gets cut with the 2. 1.2 that is 4. What do I get now? How many zeros are gone? Tell me how many zeros are gone. Look at the numbers first. 4 into 3, 12. 12 into 2, 24. 24 into 4, 96 pi. Look at that multiplication again. I got 4. 4 into 3, 12. 12 into 2, 24. 24 into 4, 96 pi. Now look at the power of 10. 10 power minus 7. 1, 2, 3, 4, 5. 10 power minus 7, 10 power 5. 10 power minus 2. With the 10 power minus 3, 10 power minus 5. Okay, so let us multiply these two numbers. This is like, you can take this as 100. No problem. When you multiply, if this number is 3.14, reduce it by a small amount and increase this by a small amount so that the product will almost be the same. Okay, you can multiply 100 into 3. You reduce this is 3.14 in fact, you can make it 3. So then take a small change in 96 also. So 100 into 3 will be what? That will be 300 into 10 power minus 5. So let us put it here. 300 into 10 power minus 5 with a minus sign into what is di? The change in current is, if you remember, it was minus 4. Okay, and the time in which this happens is 0.25 seconds, which is same as 1 by 4. 0.25 is a quarter, right? 1 by 4. Tell me what you're going to get. Minus or minus plus. 4 goes to numerator. This 4 will go to numerator, right? 4 into 4 is 16. 16 into 300. 4800 into 10 power minus 5. Okay, so take it down by 2 places. 48. 2 zeros are gone. Into 10 power minus 3 volts. 48 into 10 power minus 3 volts. 48 millivolts. Understood this? All of you got this? 48 millivolts. All of you got this? Everyone got this? Can I have a response, please? All of you, all of you. Right, the last one. I'll do this one also. I'll just give you the hint for it. The current through an inductor, 4.6 Henry inductor, is shown in the graph. The induced EMF during the time 5 milliseconds to 6 milliseconds. So you have to find what? EMF during the time 5 milliseconds to 6 milliseconds. Look at that segment. 5 to 6. 5 to 6. Okay. So how to find the EMF? How to find the EMF? You are given what? You are given self-inductance. Self-inductance is how much? 4.6 Henry. Self-inductance is 4.6 Henry. Then what? I have to find out di by dt. How to find out di by dt? Look at this. I am finding di first. What is di? What is di? This time, current is what? Comes straight to the left. Okay. What is the current at that point? 0. For this time, what is the current? Straight to the left. It is 5. 0 minus 5. So look at that. At this time, current is 0. At this time, the current is 5. So what is the difference in currents? That is going to be minus 5 amperes. Okay. So I know what to do now. EMF is given by minus L into di by dt. That is equal to minus 4.6 into what is di? Minus 5 by what is dt? Time is given 6 milliseconds to 5 milliseconds. 6 milliseconds and 5 milliseconds. So what is the difference? 6 minus 5 into 10 raised to minus 3. Why 10 raised to minus 3? Millisecond is to be converted to second, right? So finally we have minus over minus plus. 4.6 into 5 is 23. 4.6 multiplied by 5 is 23. Then 10 power minus 3 goes to numerator to make it 10 power 3 volts. So here the answer is option C. I'll explain that very quickly one more time. Look at this graph here. The graph is what? This is an important question again. They are asking you to find the EMF during the time 5 milliseconds to 6 milliseconds. 5 to 6. Oh, not during the whole time. 5 seconds to 6 seconds. The last part only. Alright. So at 6 seconds, what is the current? Comes straight to the left. That is 0. So current is 0. Final current is 0. At 5 seconds, what is the current? Go straight up. When you hit the graph, go to the left. It is 5. So initial current is 0. Final current is 0. Initial current is 5. So 0 minus 5 will give you difference in current. Difference in currents. It is minus 5. I can put it here. Self-inductance value is given 4.6. Change in current is given minus 5. And time is given 6.5. Final current is 6 milliseconds. Initial current is 5 milliseconds. So the difference of currents is 6 minus 5 into 10 power minus 3. Why this 10 power minus 3? Because they say millisecond. Milli means 10 power minus 3. Milligrams, 10 power minus 3 grams. Milliwatts, 10 power minus 3 watts. So milli means 10 power minus 3. So you get 4.6 into 5, that is 23. 10 power minus 3 goes to numerator, 10 power plus 3. 6 minus 5 is 1. So that's all from me for the time being. Did you understand this question? Did you understand this question, everyone? Everyone got this? Or shall I do one more question here? Shall I do one more question here, everyone? If you say, I'll continue with one more question and then I'll wind up. I'll hand this over to Rafi sir. Rafi sir will take from here. All of you, everyone, Can I have a response, please? Everyone, guys, tell me. Come on. What is this? We are so close to the exam. So we expect more proactive approach from you. Tell me, tell me. I'll do one last question. I'll make it very quick, like maybe like 2 minutes, and then I'll wind up. Look at this. You know, this is an important question. The current in an inductance coil varies with the time according to the graph. IT graph is given. IT graph. And which one of the following plots shows the variation of voltage with the time? Okay. So what is the equation for voltage? It is in a coil. Where is the coil question? Coil. Coil means you're talking about self-inductance. What is it? Minus L into di by dt. Minus L into di by dt. Self-inductance EMF is given by minus L into di by dt. Now let us see the question segment by segment. See the segment OA. What do you think about OA? You must know this. Whenever a graph question is given, there are only two possibilities. Number one, you will be asked to find the area. How do you find the area? There is a technique. Multiply the y variable and x variable. That would be something you know. And if you are asked to find the slope, take y variable divided by x variable. Divided by x variable. Okay. So look at the segment OA. OA means the climbing up part. Okay. For that segment, I'm taking the slope. Slope. How to find the slope? I told you how to find the slope. Y-axis divided by x-axis. Tell me, y-axis, it is I divided by x-axis is time. But or rather it is what? This is something we are searching for, right? Okay. Okay. So in search of gold, we found diamond, like that, right? What is this now? This is what? di divided by dt, right? Di by dt. That is exactly what we were looking for. And what do you think about that slope? For a straight line, slope is a constant. For a straight line, slope will be a constant because wherever you draw the angle, you know the angle will be the same. Slope will be the same. Straight line means slope is the same. So for this guy, slope is the same. Slope is constant. One more thing, it is an ascending graph. Ascending graph. Ascending graph means slope is positive constant. So let us put it here. EMF is given by minus L into this guy I've gotten over here. It is what? It is positive constant. So when you multiply these two, you are getting what? EMF is equal to minus L is a constant. Constant into constant, again a constant. So EMF will be a negative constant. And if you analyze the graph, right away you got the answer. There is only one negative constant here. No. Constant means graph will be a horizontal straight line. Okay, so that must be the option. But let us check it out. So first part I did. Second part is AB, the segment AB. Look at the segment AB. Look at the segment AB. What do you think about the slope? What do you think about the slope? That's again slope is equal to, I told you, y-axis divided by x-axis, or rather di by dt. And what about the slope here? This slope is what? Slope is again, it is a straight line, right? Straight line, right? Tell me please, straight line slope is what? Straight line slope is a constant. But as you can see, it's a descending graph. Descending graph. A graph that's climbing down has what kind of slope? Negative slope. So it is negative constant. Okay, so for that segment, I'm going to write the same thing here. EMF will be what? EMF will be what? This thing, minus L into, tell me, minus constant. Minus constant. So what is it going to be? Minus of minus plus. Minus of minus plus. L is already a constant. Constant into constant is constant. So I got positive constant. Look at my conclusions now. In the first segment, EMF is a negative constant. For this segment, OA segment, EMF is a negative constant. And segment AB, EMF is a positive constant. EMF is a positive constant. So how do we draw such a graph? Negative constant for the first part. Constant means the graph should be a straight line like this. Why it is on the negative side? Because in the first part it is negative constant. Second part is what? Positive constant. So I should go straight up and then draw it here. So which is the graph here? Answer is option C. Answer is option C. So that's it from me for the time being. Now that's all about electromagnetic induction. Now Rafi sir will join you with a topic, with a session on current electricity, and it is an important topic. Okay, so you're definitely going to get the questions if you, magnetic effects of current and magnetism. I'm really sorry for that. Anyway, that is also equally important, and you know, if you attend the session, you are sure to get at least 2 questions. Okay, at least 2 questions, particularly magnetic effects topic. That's very important. That's numerical type questions would come, and you know, you have to sit through the session till the end. Even the last question would matter. So anyway, thanks for staying back. I'll come back with another topic tomorrow. So revise all these questions. All these are very, very important and selected questions. All our previous board questions also. So see you tomorrow, guys. Thank you for coming. Bye. Yes, hello everyone. Good evening all. Good evening. Am I audible? Everything is fine? Hopefully you got a good session from electromagnetic induction from my colleague Lijo sir. And now let me start the next chapter discussion, that is moving charges and magnetism and matter, like a quick important questions we are discussing now. All right. So we can have a new thinking at such kind of questions and important expected board patterns. All right. So let's begin the discussion. Let me move to the first question. Hopefully you all guys are ready. Really important questions. So take your notebook and do the solution over the notebook. Okay. Yes. Listen to the, welcome all to the first question. Come on. Read the first question. It's a chance to ask in examinations. Okay, look at the first question, all of you. Can you read this one? Yeah, silently read, all of you. Read silently this question. And you guys can comment the answer. Without my explanations, before my explanations,
Can you find your own answer, what your mind is thinking? Then I will explain. Yes, all? Can we start? Yes, did you read the question correctly? Yes, Sean? Yes, Farhan? Yes. Hopefully you all read the questions. Now let me discuss. What is this one? Two very long, infinite long wires. They are insulated. How they are kept? They are mutually perpendicular like this. And what they asking? These wires carry current equal magnitude. Both are, equal magnitude. Currents are running. Find the net magnetic field. Find the net magnetic field at the point, basically at the point P here, okay? The point P. The point P, what's the net magnetic field? That's the question. So idea required to solve this particular question will be, let me tell you that. You guys want to remember, mainly the direction has a role here. Okay, look at this. I have an infinitely long straight wire. Okay, let me tell you, I'm making the topic first of all. What is the magnetic field at this point, which is r distance from the straight wire? You know the formula, right? What's the formula? Let me recall. You guys can recall the formula. Mu 0 I divided by 2 pi r is the formula, right? Magnetic field will be a straight wire at r distance away. And can you say what will be the direction of magnetic field? How will you find the direction of magnetic field? You guys have many rules, but I am using rule will be, this one, I will tell you that. You can follow any rules, no issue. All rules are accepted. I will tell you my easy rule, which I normally prefer this chapter. Okay, how to find the magnetic field direction due to a straight wire. Simple rule, keep your right hand along the current direction. Keep your right hand along the current direction. Then, rotate your palm and make it the palm towards the point P. Okay, it is like, I am keeping my right hand on the straight wire, saying hi to the point P. Saying hi to the point P. This moment, did you look my finger, thumb finger, where it is pointing? Inward. So here, magnetic field is pointing inward then. Suppose, you can learn that topic then. What if the point P is here? Repeat the same. If the point P is here, keep your right hand along the current. This time you record to say hi to your point where? Point is here now, this moment. Suppose. Then what will be the thumb pointing direction? Outward. Understood? Yes. So that's a very simple rule. You can follow that. Or no matter, I'm not forcing you. Physics is like a relaxed subject. You can think your own way. I'm actually allowing you that. So I'm using this rule. In case if you feel this is easy, you can also use. Keep your right hand along the current. Say hi to the point P. This moment where your thumb is pointing inward. So that's a way of identifying the direction of magnetic field due to a straight wire. Okay, guys. That's the information. You guys want to remember that many information. Now look all, there is an infinite long wire. This one, let me call this wire 1. And this is what we call wire 2. What is the wire 1 producing magnetic field here? You just find the direction. Both magnetic field are equal, right? Why? Because, see, this is same current. Both wires are carrying what? Same current. And distance to the point, distance to the point from the wire 1 and wire 2 are equal. If the current and distance are same, then both of the wires will produce what? Same magnetic field. All right. Yes. What will be the direction? So we understood that B1 and B2 are equal. Can you say what's the B1 value here? Magnetic field to the first wire, I can say mu 0 I divided by 2 pi D, where D is the distance here. Distance to the point is D. And what about B2? What about B2? Same, right? Because I will be same, D will be same. So it is same only. Okay, B1 and B2 are same. Values are same. Now look at the direction. Keep your right hand along the straight wire. You want to say hi to the point P. Where is your point P? Hey, my wife, point P is on the top. So say hi like this, where your thumb is pointing outward. So therefore, magnetic field 1 producing will be what? Outward. Let me mark like outward. What about this wire producing magnetic field at that place? Keep your right hand along the straight wire. Say hi to your point. You're a chota boy. Yeah, this moment where your thumb is pointing, andar se jayega na, inward. Inward. So look at this. B2 will be inward. So one is outward, one is inward. What happened to them? They will cancel out each other. Then what will be the magnetic field? What will be the resultant magnetic field? Resultant magnetic field will be 0, because magnetic field is a vector quantity. When two vectors are equal and opposite, then the resultant is 0. Understood? Just a tricky question. This kind of, questions we'll ask in board examinations. Understood? Did you get this? Welcome, Laddu. Today's welcome, Laddu. I hope you got a green laddu. So remember, a small concept is conveying infinite long wire. So the magnetic field at the point P. One of the very famous question. You can also expect it's an MCQ questions. Okay, they can ask in MCQ category. Hopefully you all got this one. Yes, similarly we can, cover one by one questions and based on the concept you can refresh. Okay, yeah, let me move to the next question then. What's the answer? 0. You got the reason, right? Yes. Now let's look the next question. One concept is covered. Clear, clear. You guys feel laddu? Yes, Marabai. Yes, come to the next question. Come to the next questions. Let's enjoy next. You guys want to keep it a book and do it correctly. Be cool. Yes. Come on, let's next question. This chapter, mostly we are expecting board, like a numerical pattern of questions, moving charges and magnetism. Look. Did you read this question? Yeah, 2 line only. Very chotta question. Very cute question. Come on. The ratio of magnetic field at the center of a current carrying coil of radius r to the magnetic field, ratio is asking, to the magnetic field at r distance from the center of the coil on its axis is root x is to 1. Then what is the value of x? Simple, no? Look. I think this is a self-explanatory question for you guys. Maybe. The ratio of magnetic field at the center of a current carrying coil. What's the magnetic field at the center of a current carrying coil? Let's say what's the radius? What's the radius of this coil? It is given r. Tell me the formula of magnetic field at the center of a coil. Center of a coil, mu0 I divided by 2r. The radius 2r. For infinitely long wire, 1 pi will be extra. So you can connect both of them. Okay, for an infinitely long wire, what's the formula? Just a pi extra in denominator. There's a pi wala come in niche. You have to remember that. For circle case, there is no pi. Keep it logically connect like this in your mind. Okay, fine. Magnetic field at the center will be this one. This was the first story. Now, what's the next one? This is the first one. Next one, you have a circle. At a distance r from the center. Okay, look at this. You have a circle at a distance r from the center of the coil. What will be the magnetic field? Here you have to use. I hope you guys learned that. What's the radius? What's the radius of the circle? That's also r. What is your point in the second case? Second case, axis point. Axis point, could you tell what's the magnetic field formula of axis point? Say, all of you. Mu0 I r square divided by 2 into r square plus x square all raised to 3 by 2. You learned this formula? Yeah, it's a good formula, right? Magnetic field at the axial point of a circle. Very, very important formula. I hope you guys are prepared the derivation of this. Speak the formula. Lock this formula in your mind. 1 or 2 rounds if you speak, this will stick in your mind. Tell me the formula. Mu0 IR square divided by... very happily you have to say. Mu0 IR square divided by 2 into R square plus X square all raised to 3 by 2. That's the magnetic field at the axial point. Okay, so let's substitute. What is R? R is the radius. What's X? Axial distance. What about this particular question? Magnetic field at the axial point will be mu0. I hope the students who know this, they can continue the calculation. You don't want to wait me if you got the idea. Others, please focus. 2 into R square plus, what's axial distance here? That's also R, sir. All raised to 3 by 2. You can simplify. Then find the ratio. Then ratio is given root x is to 1. Then you can find x. Can you try? Yes, I hope you can try this. Come on, anyway, let me do here. Magnetic field, the axis will be mu0 I r square divided by 2 into, what's r square plus r square? 2r square. R square plus r square? 2r square. So it's like 2r square all raised to 3 by 2. All raised to 3 by 2. Hey, this 3 by 2 is the common property of this 2 and r square. You want to give both of them. Let me do that one here. So magnetic field at the axis. Remaining part I am doing here. Yes, mu0 I r square divided by 2 into, give this 3 by 2 for this 2. For that 2. Okay, so it becomes what? 2 raised to 3 by 2. Are you getting? Yes. Then r square all raised to 3 by 2. Okay, that one. Please note that. R square all raised to 3 by 2. Here you are smelling a cancellation, right? Here you are smelling a cancellation. Now, here somebody is going to celebrate the birthday. Cut the cake. That 2 you can cancel. One more celebration. Come on. This r cube now. This r cube and this r square get cancelled. What is left? Could you tell? mu 0 I divided by 2 raised to 3 by 2, bring it out, okay, bring it out, then 2 into R only left. That's the magnetic field at the axial point, magnetic field at the axial point at a distance R. What the question asking? Look at this, what I will do then. Yeah. So you got this right. Let me do the remaining part on the top. Are you all completed this one? Yes. This formula you remember, no? Magnetic field at the center. Okay. What the question asking here? Magnetic field at the center to the magnetic field at the axis is given how much? Root x is to 1. So you can say root x by 1. What's the magnetic field at the center formula? Tell me. You guys are doing with me, right? So can I do that one here? Mu 0 I by 2r, right? 2r, magnetic field at the center, divided by magnetic field at the axis. What's the magnetic field at the axis? That ratio. Whenever you are dividing one ratio by other ratio, then denominator of other ratio goes up, right? So that I am doing here. Multiplying. Okay, BC value, right? Then B axial ratio, multiply the reciprocal. Take the reciprocal and multiply. What's the reciprocal? Come on. 2 raised to 3 by 2 into 2r divided by mu 0 I, which is equal to what? Root x is to 1. Hopefully you are getting right. You're getting right? Yes, come on. Now you can cancel this. Now you can cancel this. If you cancel this, yeah, mu 0 I get cancelled. 2r get cancelled. Then what is left here? You will get 2 raised to 3 by 2 is root x. Hey, root x you can write like this, right? X raised to half. You just square both sides. Then what will happen? When you squaring time, you can see what? 2 raised to 3 by 2 the whole square, which is equal to x raised to half the whole square. 2 get cancelled. So you will get what? You will get 2 cube only left. The 2 cube is equal to x. That means x is equal to 8. Understood? X is equal to many students got the answer, na? Great. Salute, Satvik. Yes, Hiba. Good. Good. Hiba Shamna is rocking. Yes. Great. Easy question only. Magnetic. If you know the formula, just to remember the formula, everybody can do this. It's not a genius question. Okay? It's easy question only. Magnetic field, the center of a circle, axial point of a circle, we are done. I hope you got the calculation right. The presentation of the answer will be somewhere I wrote here, there. You can check if in case if you needed, you can go back like after this calculation got over or the live got over, you can go back and watch it, okay? In case if you needed the repetition. All right, let me go to the next question. I'm quickly go to the next question. Yes, all. So we done, one topic based questions. Too many connections are there. Too many like concepts are touching, right? Let's break another question now. Focus this. Welcome all to the next question. Hello all. Please focus, okay? Give your attention. Okay, your mind want to open. Okay, in case you are not, don't worry, okay? Come on. Just to do this one. A long wire carries a steady current. Steady current. It is bent. There is a long wire. Yeah, you guys can think, right? First of all. Yeah, that's great. You guys can think first. Okay, let me write here. There is a long wire of length L. It's not given, say length L. Wire steady current I. It is bent into the circle of one turn. There are some case were mentioned. Let me use like some space here then. Okay. At the beginning itself, let me manage the space. This L length wire. So case 1, there are 2 stories are mentioned here. When you read this question, you can see that. This L length wire going to bend into one circle. Okay, I have a L length wire, just imagine, okay? Then bend into one circle. That's what the question said. All right. Now you are getting some point here. Yes, the length of the wire is equal to circumference. Are you striking that point? Then you are very good. Appreciated. If you think so, then you are great. Okay, that brain only needed for surviving the life. Okay, yeah, that you have. Don't worry, kids. Come on. So, a long wire carries a steady current bent in the circle of one turn only, okay? The magnetic field at the center of the coil is, now the magnetic field center of the coil is how much? B. Can you say what is the magnetic field at the center? You learned that formula, right, for the previous problem. What's the magnetic field center formula? Mu 0 I divided by 2 pi r. Sorry. It's not. It's like a circle, right? Circle. Mu 0 I by 2r only. 2 pi r for what? Infinitely long wire r distance away. Okay. So this is the magnetic field at the center of circle. Hey, this is what given there. It is given here. It is B. It is given it here B. So mu 0 into I divided by 2 into R. What is R? That we can substitute. That I told in the beginning. So this radius is R. How can you find the radius? Yeah. So the length of the wire is made entire circumference. So we can say length is equal to 2 pi R. So what is R then? Length by 2 pi. Can you substitute here that R value? Yes. So here L by 2 pi. L by 2 pi. This is what B. What do you wish? Can we keep this one, or you want to bring 2 pi up? You can do. No issue. Okay. You can keep as it is. Yes. I'm waiting. I'm going to the next part then. I'm reading the next part. Okay. Come on. Next part you should read. Everything you can do only. Okay. It's not for only for the toppers. It's not only for the average students. Everybody, if you work, you can also make stronger in physics. Okay. Come on. It is then. Now the case 2 they are saying, listen, the L length wire is gonna bend into circle of n loop, n turns, not one turn. How it is possible? Oh, I don't have a wire now. Let me show you from my watch. Okay, just imagine. I have a L length of wire. The watch is not that much good. Okay, sorry guys. Yes, L length wire is bent into one circle. Means like this. The same L length wire I can bend into many turns, na? Chota turns. That's what this question said. That's clear? All right. So here this is going to bend into n number of turns. I'm not bothering about the diagrams. Imagine here how many number are there? N number of turns are there. Then they're asking find the magnetic field at the center of the coil now. What is the magnetic field at the center of the coil? Tell me. There is a mistake you might make here. Magnetic field at the center of the coil will be, sir, mu 0 I divided by 2 pi r. Wrong. There are n number of turns. Use your brain. There are n number of turns. So it's mu 0 I divided by 2 into, is it r? No, R dash new radius. This R dash new radius. Because R you called, when one turn, it is R. Hey, when it is like, entire length of the wire, when you make one circle, radius is R. When you make like n circle, is the radius the previous one? No, it's become small. That radius you can call what? R dash. That R dash you have to find. That's fine. Now, tell me the R dash value. How to find R dash? That's very easy, na? For this circle radius, what we called R dash. Again, the same concept. The length of the wire is equal to not circumference. It's equal to n times the circumference. Okay, understood? One circumference, how much? 2 pi r dash. How many circumference are there? N times, because we made n turns. So, what's r dash become? Tell me what's r dash become? L divided by 2 pi n. Samajhiyo? Understood? Yes, sir. Then substitute here. Yeah. So, BC will be n into mu 0 I divided by 2 into r dash. What's r dash? L divided by 2 pi n. Now, what happened to this? I am only bringing n up because I already kept 2 pi here. Look. Shant se dekho. This n goes up, and n into n become what? N square, sir. Okay, that's great. N square. Can you look what is the remaining terms? Is this color is okay? Is it Minha is there today? Minha, this color is okay to you? Yeah, look. This one, okay? This one. That enveloped content. Is it color visible? Yeah. That, and look over there. What is that? Yeah, that is equal to B, right? That's equal to B, right? Look at this term. That's exactly same, right? So you can call this is n square times B. N square times B is the final answer. That's okay? N square times B is the final answer. Clear? If the one turn making time magnetic field center will be B, then if it's same length of the wire bent into n turns, then center will be how much? N square times B. Clear? Understood? Yes. Let me move to the next question then. I hope you guys are okay with this. Clear, clear, clear? Clear, understood? Understood? Yes. You know, through a question, you are getting several points. I'm connecting several points to you. Yes. Can I move to the next question? So, N score B is the right answer, okay? Yeah. Look on the next question. Everybody please read the next question. Welcome the next question. Yeah, make it fast. You can think. You guys can think. Very focus, okay? Very much focus, because every question is not, the question which I said here, it is not like a, direct approach questions. Because direct approach questions you've done many times, no? So now we are focusing on, little bit twisted manner. If it comes in examination, how to break. To break that, I'm giving some confidence to you. That's what I'm just giving this kind of question. This is the maximum level you can expect for the board examinations. Come on. A long wire. Through this question also you will get several informations. Come on. A long straight wire of radius is what? A. Radius is what? A. Radius is A. Carries a steady current I. Carries a steady current I. The current is uniformly distributed across the cross section. Radius is A. The ratio of magnetic field at A by 2 to A from the axis. One of the CBSE board loving question. So one of the previous pattern. Okay, so keep in your mind this. To solve this question, you guys want to remember some formulas. Okay, some formulas that I will write here. Okay, so that is, let me repeat that topic to you. Yes, everyone. So dhyan se dekho. Yes, there is a straight wire. And what is the radius of the straight wire? Tell me, what's the radius of the straight wire? Radius straight wire, what is given in the question? Radius straight wire? Yeah, it is A, right? Radius straight wire is A. So radius of the straight wire is A. Or in general, we can say what? What's the best letter for the radius? What do you feel, Professor? R. Oh, yes. The radius, okay, radius of the wire is R. You can consider. So, here you want to remember three formulas. Magnetic field outside the wire. Magnetic field outside the wire. That we learned, right? Magnetic field outside the wire. What's the formula? Magnetic field outside the wire, sir. Magnetic field outside the straight wire. That we learn now. Straight wire. Mu0 I by 2 pi R. 2 pi R. Here there are two R are there. One is, distance from axis to the point P. One is the radius of the wire. Okay, both are small r and capital R. Don't get confused. So outside the wire, what's the magnetic field? Mu0 I by 2 pi R. Mu0 I by 2 pi R. One more question, similar question is coming. So let me discuss both of the questions content at same slide. Okay. So here you can see what? Magnetic field outside the wire. How it varies, all of you. How it varies? Sir, it is inversely proportional to distance, right? Look at that. B and R, how they vary? Inversely proportional. Look at this. As distance increases, what happened to the magnetic field? Decreases. Okay, so remember that one. Outside, how when you go far, what happens to the magnetic field? Decrease. Then one more formula you guys want to remember. What is the magnetic field at the surface of the wire? Surface of the wire. Very simple now. That logically you can connect. See, when this point become to the surface, when this point P comes to the surface, suppose when this point P, when the point P, slowly, dhire, you bring toward the surface. Come on, let's bring that point P toward the surface. That moment, what the distance become? Tell me, what the distance become? It is equal to radius. So when you put R is equal to radius, then you will get what? Mu0 I by 2 pi R. That's the formula for what? Circle. Center of the surface. Center of the surface of surface of a straight wire. Correct now? Yes. Then magnetic field at inner side, okay, inside straight wire, inside a straight wire, mu0 I into R divided by 2 pi R square. 2 pi R square. There's a formula there. Don't confuse about it. If suppose the point P come towards inner side, then what will be the magnetic field? Variation will be a little different. Mu0 IR divided by 2 pi R square. Okay. So here, how is the magnetic field and distance varies? Inside, sir, it is inside variation. Look at this. Inside variation. It's not working there. Okay. So let me write here then. Magnetic field inside variation. Magnetic field inside variation is directly proportional to distance. Directly proportional to distance. What I am talking? I am talking about, solid conductor. Okay. Solid conductor or solid cylinder. Remember, okay, I have one more question to show similar. So I make it detail. It's a solid. That means inside is not empty. Inside is not empty, fully filled. Okay, it's a solid cylinder. We have a discussion of hollow cylinder also there. I will tell you that point. So this is the variation, right? Now focus on this. What do you guys want to remember here? There is a famous graph is there. That's also asking question. Magnetic field versus distance graph of a straight wire. Yeah, look at this. When the distance is equal to 0. When the distance is equal to 0 means the point P is where? Along the axis. When you put R is equal to 0, the inside point, what you will get? You will get magnetic field is 0. So, when R is equal to 0, what's the magnetic field? 0, because R is equal to 0 means what? Center or axis. Center or axis, you can say. Then what happened here? Small r is equal to capital R. Sir, small r, when the distance becomes capital R, what's that point? That point is called the surface. Surface. This region is what? Center to surface means inside. Inside, how it is vary magnetic field and distance? Directly proportional. So graph will be like this. And after the surface, if you again go how the magnetic field varies, outside magnetic field variation, inversely proportional. Inverse proportionality means when distance increases, magnetic field decreases. So the graph will be as the distance increases, magnetic field decreases like this. Okay, so that is the graph, magnetic field versus distance graph of a straight wire, not straight wire. Remember, solid cylinder, or we can say solid wire. There are two types of wires are there. I will tell you in depth. Hollow cylinder is also there. I will tell you. So hopefully you all got this formula, right? You record by heart that formulas. Mu0 I into I by 2 pi r is outside. Surface will be mu0 I by 2 pi r itself, but this r is the radius, or radius of the wire. Inside what's the formula? Mu0 IR divided by 2 pi r square. Remember the graph? I think you might get a question from this particular part. I hope derivation is also important. I hope you guys learn the derivation. NCERT textbook, blue colored, like a solved example is there, which is a very, very famous derivation, which is a usually asking derivation. So hopefully you will learn this one. All right. Yes. Let me come to this question now. Yeah. Here, a long straight wire, radius is R, carries a current I. Current is uniformly distributed across the section. The ratio of magnetic field at A by 2, at 2A. Look at this. What is that? A by 2 and 2A. You have to think now correctly, okay? So this is a straight wire. This is a straight wire's axis. What's the radius? Tell me what's the radius. Radius is, tell me what's the radius. Radius is A. And can you say what is the first point? A by 2 from the axis. A by 2 from the axis or A by 2 from the axis. What is A by 2 from the axis? That is inner side, right? A by 2 only. When you travel from axis to the surface, how much distance? A. If you travel A by 2 means you are halfway from the axis. So it's A by 2 means inside. What's the magnetic field? Inside. Yeah. So at R is equal to distance is equal to A by 2. You are inside, right? You are inside. Inside, what's the magnetic field formula? Inside formula become mu0 I into R. Multiple times right. Then only you will remember these formulas and all. Mu0 IR divided by 2 pi R square. 2 pi R square. So magnetic field inner side will be, we can say, inside will, let me call this one B1. Okay, let me call this point is B1, okay? First point. So I can handle easily then. Mu0 I into, what is R? R is A by 2, sir. Divided by 2 pi into, what this R? Radius, sir. 2 pi A square. Correct, no? Okay. Now see, you can cancel. The 2 comes down, right? And this A, 1A get cancelled. What will you get then? Can you say? Mu0 I divided by, the 2 comes down. So you will get what? 4. The 2 and 2 meet. And 4 pi A. You will get B1 is this one. Am I correct? Correct, right? The calculations? Check it, okay? Check and tell me. Expecting I am correct. Okay, fine. And then look at the next part of the question. Next part of the questions. Don't worry, okay? At the first attempt, lesser number of people only solve this one. Keeps on practice. If the same question come, the similar way of thinking question come, you can do. Okay, come on. So then next place. What's the next point? At a distance R is equal to 2A. Correctly identify. When you travel a distance equal to double of the radius, where you are now? You are out. This is A. If you travel to a distance, you are out. So outside. Outside formula will be, you are out, right? You are outside. Outside formula, outside formula will be, tell me the outside formula. Outside formula is mu 0 I divided by 2 pi, that distance. Okay, so let me call this B2. I'm calling this B2, okay? Mu 0 I divided by, tell me guys, what is the distance here? Distance from the axis? 2a, that is 2a. How much you will get? Mu 0 I divided by 4 pi a, that is what B2. What about B1? B1 and B2 are same. What's the question asking? What's the question asking? Ratio, right? Ratio. What's the ratio then? 1:1. Because B1 and B2 are same. So ratio will be 1:1. Okay. Since B1 equal to B2, therefore B1 by B2 is 1:1. Okay. Therefore, I can say the ratio. The ratio I can write B1 is to B2 will be 1:1. Sir, we done this much. Then answer is 1:1. Okay, leave it. You got the concept, right? Yeah. Then what they will change? They will change the values. Then they will ask the question a by 3, like 4a by 3, like kind of questions will come. So substitute those data. I hope your mind is developed to solve this kind of pattern. Yes or no? You got the informations, right? You got the informations, right? Yes, all. Can I move to the next question? Can I move to the next question? Are you guys are with me? Are you guys are with me? Are you guys are with me? Yes. Let me move to the next question then. Yes. So, yes. Dulquer Salman. Who is that? Dulquer Salman. Yes. Yes, Dulquer Salman. Let me move to the next question. Let me move to the next question. Johnson Joseph. All right. Let me come to the next question. This question content also I discussed before. Can we connect now? Yes. I think you guys got wrong answer now. I think you guys got wrong answer now. Why? I will tell. I told you, it's not direct questions. Yes, a surprising question to use. You guys, don't worry, okay? Don't worry. I'm not breaking your confidence. I'm just breaking the confidence. So when you go to gym and all, what actually the trainer will do? They will take, they will give like too much weight and all, right? Why it is so? When you do such kind of exercise and all, your muscles will break. They are breaking, then growth. Breaking, then growth. Cells get divided and growing, right? Similarly, I'm just training you that level. I'm breaking you and breaking you the physics points, then you will grow, children. Don't worry. For this time being, your confidence become lower. Don't worry. You will get lot of informations. You are growing that you are not knowing now. Yes. Come on. Let's look at this question. An infinitely hollow, the word. Hello, dhyan se dekho. Hollow, conducting cylinder. Solid conducting cylinder, we learned. This is the graph, right? Solid conducting cylinder, that's a graph. But hollow means inside is empty. No current is passing inside. Okay, it's like, this way. It's hollow. It is hollow cylinder. You can let me draw that diagram to you. So the hollow means like this. Okay, only mass is present here. Mass is present here. Inside is cavity. Current is only going through these regions. No current is passing inside. So there is no magnetic field. So sir, why there's no magnetic field? How to prove that? That's very easy. Yeah, you can, this axis, right? You can consider what? There is an Amperian loop. Ampere circuit law. What's Ampere circuit law? Integral B dot dl is equal to mu 0 times I. I stands for what? Current inside the loop. What's the current inside the loop here? For this loop, there is no current, sir, because there is no mass here. Then how current can flow? Current means what? Charge flow, right? Charge only flows through the matter. So here no matter is present. So what's the current whereby? Current enclosed will be 0. So integral B dot dl 0 means B will be 0. So what's the magnetic field inside when when it is a hollow cylinder? Inside will be 0. Rest of the outside will be formula same. Outside will be mu 0 I by 2 pi r. That is same. But surface also same. But inside will be what's the magnetic field? It is 0. Therefore, option C is the right answer. Careful. What this option for what? Solid cylinder. Inside is, so very carefully read that, is a hollow. So inner side, inside, R is equal to 0 to capital R. Like there is no magnetic field. Okay. Yes, sorry, Afrin Salam. it is not solid cylinder. Okay, friend, you are very careful. Solid cylinder will be this one, hollow cylinder will be magnetic field variation. That's another additional information to you. Just keep in your mind, expecting you understood this. So note down this content, okay, so that you can utilize its revision. Can I go to the next question? Yes, sir. Next question. It's a very famous pattern. So I can't avoid this question. I can't avoid this question from moving charges and magnetism. Normal level discussion we did multiple times. So, but we can't separate this. We can't separate the student who are learning moving charges and magnetism can't avoid this question. Such a repeatedly famous pattern from moving charges and magnetism. Can we do this one? Did you read this? Did you read this one? Read it carefully, all of you. Please read. A rigid square loop side carrying current is what? I2. Square loop carrying what current? I2. Okay. Lying in horizontal surface. Both are, imagine square loop is here, current is here. It is like this, okay? Square loop, and a current carrying conductor. Square loop. Imagine horizontal plane. We can't draw in a book, it's like a board I kept like vertical. That's why it is showing like this. But it's an horizontal. Don't worry, just leave it, no issue for it. If you can say like vertical, horizontal, no matter, does not affect here. Yeah. Current in the wire I1. So net force on the loop. Net force on the loop due to the wire will be. What's the net force on the loop to? Come on, let's find that. Yes, to solve this question, let me give again the information to you so that you will get a revision also. Yes. Focus on this, okay? I have a parallel current carrying conductor in which it carrying what current? I1 and I2. Let's say it is separated by a distance d apart. Do you know what happened to the like currents? Sir, like currents will repel. So like currents will be attract each other. Okay, they will attract each other. So that conductor will exert force on his, and this conductor will exert force on that wire. So automatically what happens? They get attracted. I'm not going into that much deep theory because you guys are prepared already that. What is that mutual force? The mutual force between the wire will be mu 0 I1 I2 divided by 2 pi d into the length. Force on L length wire, parallel current carrying conductor. How much force acting on L length portion of any wire will be? What's the formula? Mu 0 I1 I2 by 2 pi d into L. Okay. So I told in this chapters, if you learn the formula, you might be able to solve the numerical. Mu 0 I1 I2 by 2 pi d into L. This is the force on a L length wire, L length parallel current carrying conductor formula. Understood, right? Yes. So mu 0 I1 I2 L divided by 2 pi d. All clear? Yes. So when it is like unlike currents, when it's unlike current, what happened? They repel each other. They repel each other with the same force. All right. So learn the formula, all of you. With the help of this idea, can we go back to these questions? Let's focus on this question now. Yeah, we had to find what's the force on this loop, right? What's the force on this loop? Look all. Here, I'm not thinking about the all other portions. Let's focus on this area. Okay, let's focus on this one. What is this one? Yeah, what is this one? It is a straight wire. Yeah, this is a straight wire. It's a straight wire. You hide this one. And it's a straight wire. It's in front of what? A parallel. In front of a similar parallel wires here. Obviously, what will happen? Look at what's the current here. Current here is downward. What's the current here? Upward. So these two are what? I can say what? Tell me. I can say it is unlike currents. So these two are unlike currents. Unlike current, what will do? Repel. So that means this wire repel this portion to the right side. So there is a force to this side. Okay, there is a force to this side. Understood that? How this wire is experiencing a force like this? Because there is a unlike currents are there. Unlike current will be repel each other. Not like charges. Charges, like charges repel, unlike charge attract. Unlike charge attract. But current is just opposite. You got that? Can you say that force value? Let me call this F1. Force over here. Okay, F1. So what's the formula for F1? F1 will be mu 0 I1 into I2 L. What's the length of this portion? We are talking about the force on this. What's the length of this one? A. So that is A. Hopefully you have the formula, right? 2 pi into, what's the distance from this wire to this wire? Small a. So 2 pi a. 2 pi a. That's clear. So that's what F1. I marked the direction here. So you guys can cancel that A and A. That's a kid level. Anyway, me also cancel that. A and A cancelled. Mu 0 I1 I2 by 2 pi. Okay. So what will be the force over then the next portion? Could you tell? What will be the force on this wire? This wire. Leave it about all other parts. Now focus on this one and this. How they are? Hey, now you should bother about this one, this wire and this wire. They are like currents, no? Like currents, what will do? They attract each other. So this current attract, it's calling them to back to this one. Okay, they are pair. Okay, they are like currents, they attract each other. So the force will be like this. Understood? So what is the force? That will be called this F2. Okay, let me call this F2, force over the F2. What's F2 value? Can you say what's F2 value? F2 values are the force on a parallel current carrying conductor mu 0 I1 into I2. Current here it is I2, there is I1. And what's the length of this one? A. Length of that one is A. Divided by 2 pi. Very careful. What's the distance to this position? A. What's the distance? D means distance. Mu 0 I1 I2 L divided by 2 pi D. D means distance. What's the distance from here to that portion? Is it A? No, it is not A. This much is A. This much is also A. It's a square loop, right? So it's also A. So what's the overall distance then? 2A. So here you record substitute what? 2A. That's the difference. Okay. Then you guys can cancel this. Yeah, this A get cancelled. So you will get mu 0 I1. It's not visible. Mu 0 I1 into I2 divided by 2 into 2 pi. 2 into 2 pi. Hopefully I'm correct. That's what F2. Okay, that's what F2. Now what's the total force? F1 is in that direction. Force on this loop. F1 is that direction. F2 will be like this. So both are opposite, right? So net force, how will you find? That is, when two forces are opposite, how will you find the net force? Greater one minus lower one. Greater one minus lower one. Which is greater here? F1 is greater, right? F2 is weak. Why? That's one thing you can analyze from here itself. Denominator for this one is less. The denominator is more here. Denominator is more means F2 is less. F2 is less. Or by common sense, this wire, you know, it's actually repelling from very close. Okay, this attraction is to the far side. Okay, attraction to the far side. Obviously, this will be more, no? This will be more. That way also you can analyze. So F1 will be what's the value? You subtract F1 and F2. What is common here? Let me do the subtraction very quickly. Mu 0, I1, I2 I can take common. Divided by 2 pi also I can take common. When I subtracting this term by this term and this term, I can take that common. What is left then? 1 minus 1 by 2. 1 minus 1 by 2. 1 here, 1 by 2 here. So what's 1 minus 1 by 2? 1 by 2. Okay, so 1 by 2 into 2, 4. So I will get what? Mu 0, I1, I2 divided by 4 pi. All kids got this answer, right? So that will be the answer. I hope I am correct. Mu 0, I1, are you get the same thing? Mu 0, I1, I2 by 4 pi. What's the direction? Yeah. When two forces are opposite direction, how will you find the direction? Yeah, their resultant will be subtraction, but the direction of the resultant will be the greatest one direction. When two guys are fighting, who will win? The one who's stronger one, right? Similarly, F1 and F2 are fighting. Who will win? F1 will win. So F1 will be the dominate. So direction of the result will be F1 result. What's the result of F1 here? Repulsion. Okay, F1 will be repulsion. So what happened to this rectangular coil? It moves away. Repulsion. So look at this. It's actually repulsion. Repulsive force. This much repulsive force. Net force on the loop is this much repulsive force. Understood? This much repulsive force. Correct now? If you change the direction of current, here in a current is like this, right? If current is opposite, then you can do similar question, then you will get what? Attractive force of this much value. Hopefully this is fine. This concept is clear. All questions are, very detailed explanation I given here, like connecting to the, you can, with the help of this content, you may able to break more questions. Okay, that's great. Yes, let me move to the one more question to you. Yes, come on. Hopefully this is fine to you. Let me go to the next question. This is one of very great questions. You guys can look. Yeah, can you read this one? Now come to the next story. A conducting loop carrying current is I. This loop here carrying current is how much? I. Placed in a uniform magnetic field. Magnetic field is what? Pointing inward. And the loop will have a tendency to, what happened to this loop? So basically it's one of the demonstration experiment. But we don't have a time in that. So look here anyway. What happened to the circular current carrying loop if it is placed in this kind of magnetic field? Magnetic field is not only present here, everywhere it is, okay? Everywhere similar field is there. Okay, then what will happen? Look at this. You want to understand this concept very carefully, then you can answer what if the current is opposite, etc. You can think easily. Come on, let's solve this one. Not solve this one. Let me take a small portion in this circular coil. Taking a small portion in the circular coil. What small portion of circular coil? Sir, it's a straight wire, no? It's like a straight wire. So, is it simply straight wire? No, it's actually a current carrying small straight wire, right? You can answer like this. It's a small straight wire. Circle you can consider what? Small straight wires. And how the current is going here? How the current is going here? Tell me how the current is going. The current is going here upward. Current is going here upward. What will be the force acting on this conductor? What will be the force on that straight wire? How will you find? Keep your right hand along the current such that your palm side should be towards the magnetic field. If you find the magnetic force on that straight wire, if you find the magnetic force on this straight wire, you guys can see that thumb is pointing where? Thumb is pointing where? Thumb is pointing to the left side. You guys can find that direction. So the force on this small portion will be like this. Force on a current carrying conductor, I into L cross B. Sometimes you guys may use Fleming's left hand rule. You can follow that, no issue. Okay. So similarly, can you try what will be the direction here? You guys can try. You can see that moment if you keep so, you will get the magnetic forces like this. Over there, magnetic force like this. What about here? You guys can see this here, the current is circulating this way, right? The current is circulating this way. It's going down. This moment, if you try the rule here, you guys can see that force is like this. Whichever the rule is comfort, you can follow that. Fleming's left hand rule. I'm not actually changing the rule which you learned because this is almost the end of the year, right? Yes. Now, whichever the rule you are comfort, you can follow that. Yes. So here, current is going down. So what will be the force? Tell me what will be the force here. The force here, it is to the right side. So everywhere, if you find the force, you can see what the force actually, magnetic force actually stretches this loop. Magnetic force will be stretches this loop. So makes what? It expands. It's a quality question. It expands. It expands. Because of this force, magnetic force, the coil get expand. Understood? If the current or magnetic field suppose changes, then it will contract. You can check that direction. Okay, you can check the direction. You can think about the opposite way. In case what happened when the magnetic field direction changes, maybe it's outward. That moment the force will get what? Inner side. So it actually contracts. Okay, you can think the all possible questions from this particular part. I hope you got this idea. It's a great question. Okay, sometimes they might ask justification and all. It's a very quality question. It's first time asked in the JE examinations before. All right, hopefully you got this idea. Let me go to the next question then. Okay, I'm winding up. I'm quickly winding up. Shorter questions only, not harder questions. You guys, please wait because you guys still don't know what you want to learn in magnetism and matter topic. Is there numerical? Is there? I got a message today also. What type of numericals are there in magnetism and matter? It's just a few 3 numericals. I will wind up the sessions with that. Okay, so look at this. A bar magnet. It's a question from magnetism and matter. Now we are opening magnetism and matter. A bar magnet having magnetic moment. What is that? Bar magnet magnetic moment represented by what? M. So in case if you are not learned this topic, at least you learn the equation, then you might be able to solve the questions. Magnetic moment is represented what? The value M, which is given. And direction of magnetic field. Magnetic field value is given. What's the magnetic field? 14 into 10 to the power minus 5 Tesla. All are SI unit. I am not writing that. And the work done to rotate a magnet slowly. There is a magnet here. Imagine there is a magnet here. North, and here you can see south pole here, north pole here. The magnet is now, tell me, the magnet is now slowly rotating to the 60-degree angle from the field. Okay, from the direction of the field. Look at this. Here some external magnetic field is there. What is this one? External magnetic field. Where this bar magnet is kept, if the magnet is kept some external magnetic field. Okay, so external magnetic field how to produce? That some the other magnets are present. Think about like that. So what will be the work done? Work done to turn this magnet from this particular position to 60-degree angle. Guys, please remember the formula. Work done to turn a magnet. Not only the magnetism, it's also electric dipole. Also similar equation is there. M into B into, speak the formula with me, cos theta 1 minus cos theta 2. This is the formula. Okay. In case if you use like electric dipole moment and electric field, then you will get work done to rotate electric dipole from one angle to another angle. What's the formula? Recall all. W is equal to PE cos theta 1 minus cos theta 2. Okay, this is the work done to rotate a bar magnet from one angle to another angle. What theta 1? Are you confused about theta 1? Theta 1 is the initial angle. Initial angle. What angle? Initial angle between magnetic moment and magnetic field. Initial angle between magnetic moment and magnetic field. See this one? What's the magnetic moment direction? Tell me. For a bar magnet, magnetic moment is considered as a south to north is basically the direction of magnetic moment. You can note down this one later. What's the direction of magnetic moment? South to north. For a bar magnet, what's the direction of magnetic moment? South to north. For electric dipole moment, what's the direction? Negative charge to positive charge, like you learn, right? Yes. And theta is what? Angle between magnetic moment and magnetic field. How the magnetic moment is here? Magnetic moment initially it is along the field. So M and B are sleeping. So what's the angle then? Theta 1 is 0 here. Theta 1 means initial angle, 0. What angle? Final angle. Theta 2 means final angle. What's the final angle you want to rotate? 60 degree. So theta 2 is 60 degree. All datas are given. M is given, B is given. Don't worry, just a simple substitution, numerical, magnetism and matter. If you do that substitution, tell me the answer. M is how much? 2 into 10 to the power 5 into B is how much? 14 into 10 raised to minus 5 into cos theta, cos 0 how much? 1, cos 60 how much? 1 by 2, right? Cos 60. If you do that, how much you will get? 1 by 2. That 1 by 2 and these 2 get cancelled. You will get what? 14 only, right? 10 raised to minus 5 and plus 5 get cancelled. So work done is 14 Joule is the answer. Easy question only. This is one of the question you can expect for the magnetism and matter topic. Okay, what's the work done to rotate a dipole from stable equilibrium to unstable equilibrium, which is a very famous one. What's stable equilibrium angle? Theta 0. Unstable means what? Theta 180. If you substitute that, you will get work done to rotate stable to unstable. Remember that concept also you had to clarify. Okay, this is one question from magnetism and matter. Look at this. Next question, very easy question only, direct questions. Yeah, this is what we have done, right? Look at the next question. The relative permeability. It's also very famous questions from magnetism and matter, though not that much important that lesson. That lesson is mostly asked the questions from ferromagnetic, diamagnetic and paramagnetic comparison with examples. That's usually repeatedly asked questions. And like sometimes they ask like a few questions like this. Last chota question, you can take this one also. The relative permeability of an iron. It's written like mu r. Mu r value how much? Mu r value that is 6000. Easy question, okay? Don't forget this pattern. And what's the magnetic susceptibility? Don't worry, hey, don't fall in sleep when you hear that word. Come on, magnetic susceptibility. Can you say? Or magnetic susceptibility, right? What's the magnetic susceptibility here? That's what the question asking. What's the relationship between relative permeability and the susceptibility? Mu r is equal to 1 plus chi. Okay, so susceptibility, mu r is how much? So, or susceptibility, how will you find? That is mu r minus 1. So what's the mu r here? 6000. If you know the subtraction, if you know this formula, then all guys can easily solve this. Okay, 6000 minus 1. How much it is become? Okay, this will susceptibility have no unit. So this kind of answers, this kind of questions will come from magnetism and matter. That's all about the today's session. I hope the session is very useful to you. We discussed the electromagnetic induction concept and moving charges and magnetism. We will discuss tomorrow also like short kind of questions, okay, like from the upcoming chapters. Hopefully you saw the promo of that particular sessions, chapters, etc. Okay guys, hopefully you all noted this content. Please study well. All the best. We can see